topic for the unit over chemical reactions. And in the last video, we predicted products. So we went through, you have to identify what type of reaction you have. Once you identify what type of reaction, then you can predict what you're going to make when the two things react together. In this final step, we're going to look at the different types of products that you make, and you're going to identify the state of matter of those products. So when you're looking at your different states of matter, you have solid, you have liquid, you have gas. So a gas, you're going to put a G. A precipitate, a solid, you're going to write an S. If it's aqueous, that means dissolved in water, you put AQ. And if it's a pure liquid, you put an L. So you have solid, liquid, gas, aqueous. The most common thing that you're going to see in this class are you're going to see aqueous substances, and you're going to see pure solids. So with those two, you're actually going to end up using a chart to decipher if it's an aqueous substance or a solid, or what's called a precipitate. And then there's a few other rules on top of that that we're going to do. So you're going to need your periodic table today. And on the back of your periodic table, I don't see mine that's laminated, but on the back of the periodic table there's a chart that looks like this. Mine's a little bit bigger, it's blown up just so that way we can use it for the lab today. But on the cardstock periodic table that you either picked up from me before school started or after school started, or that you got from me on the first day of school when you reported here, we're going to use that chart to figure out if something is aqueous or something is a solid. Before we get to that point though, there's a few other things that we need to decipher. And the first one is we need to give an official definition for a precipitate. Now you have seen precipitates in many of the labs so far this year, but they are insoluble solids. Insoluble means that they do not dissolve in water. So if you put something into water, it's insoluble, it just means that it doesn't dissolve away. So if you have a precipitate, that is a solid product. If you have an aqueous substance, that means that it does dissolve in water. So you would write AQ in your parentheses after your compound. So if something is soluble, it's aqueous. Insoluble is a precipitate. So we're going to use that chart that I was talking about on the back of your periodic table. It's actually at the bottom. If you need a new one, in the chemical reactions file folder, also in the odds and ends reference materials, I can't remember what I called it. It's the black file folder for the semester. It says back of periodic table. You're going to need that chart. And with that chart, you're going to use that to identify if something is soluble or if something is insoluble. So if something is aqueous or if something is a solid. The chart looks like this, and I've also got it on a piece of paper that I can actually write on. But when you look at it, it says ions that are soluble in compounds. So if you have any of these things in your actual formula, it's going to be soluble. Soluble means that it's aqueous. In this column here, it says ions that are insoluble compounds. So if you have any of these things, so if you have carbonate, chromate, phosphate, anything on this list, it's going to be insoluble, so that's your solid. Now you do have this other side, like these two, and those say exceptions. And what the exceptions do is it throws it to the other side of the chart. So how this is read. Sulfate is always soluble. So sulfate in a formula is always going to dissolve, except when you have calcium, strontium, barium, or lead. If you have any of those four things, it's no longer soluble. We're throwing it to the other side of the chart. It's insoluble. But if you have bicarbonate here, bicarbonate is always. There's no exceptions to that rule. It is always soluble. So when you go on and you take AP Chemistry, there's a lot of these that you're going to have to just memorize, like group 1 ions. Group 1 is group 1 of the periodic table. So if you have sodium, if you have potassium, if you have hydrogen, if you have lithium, I'm trying to pull these out of my brain, rubidium, francium, any of those from group number 1, those are going to be always soluble, so they're always aqueous. On this other side of the chart, the way that you read it, like if you have carbonate, carbonate is always insoluble, so it's always a solid, except when it's combined with group 1, So if you have potassium and carbonate, we're no longer an insoluble solid. It's the other side of the chart, it's aqueous. Or ammonium. And then down here, if you have sulfur, which is called sulfide in a formula, it's always going to be a solid, insoluble, unless it's combined with group 1, calcium, barium, strontium, or ammonium. So if you have any of these examples over here, we're no longer insoluble, it makes it soluble. So this is kind of two separate sides of the chart. It kind of gets broken down this line right here. All of these are going to be soluble. These are all going to be insoluble, except when you have the exceptions. So when I went through that, look at some other things, there's some oddities that kind of happen that we need to kind of line out before we get to the examples. The first thing is if you have H2CO3, carbonic acid, as a product, not a reactant, but as a product, it goes through what's called a secondary reaction. And with that secondary reaction, H2CO3, carbonic acid, is automatically going to break apart into water and carbon dioxide gas. So you would just draw a line through that one, and instead of having H2CO3, you're going to write down H2O plus CO2 and whatever other compound it has. That secondary reaction is a secondary decomposition reaction. Now, two other things that you need to just know. Water for our class is always going to be a liquid. For the states of matter, yes, I know sometimes it's a vapor. However, for this class, to make it plain, simple, easy, if you have water as a product, it's always a liquid. Carbon dioxide is always a gas. So these are two things that you just need to know. Water is always a liquid, carbon dioxide is always a gas. Now your diatomic elements, when they are all by themselves, not in a compound, but all by themselves, your diatomic elements are always going to be a gas. So right here, always a gas. Except bromine is always a liquid, iodine is a solid. So all of your Brinkelhoff elements, BrINClHOF, diatomic elements, they get a 2. All of those are always going to be gases, except bromine's always a liquid, iodine's always a solid. And then as far as all of your other elements go, when they are all by themselves, everything else is going to be a solid, except mercury's a liquid. So everything gets taken care of by the time we go through Brinkelhoff, and by the time we add in your mercury, everything else on the periodic table is a solid at room temperature. So looking at your chart that we have here, so I have a copy of it. Let me make this a little bit bigger, I'm sorry. There we go. This is the same thing, except it's just on the piece of paper here, so I can write on it. So it says ions that are soluble. So all of these are always going to be soluble, which means that they are always going to be aqueous. Insoluble right here means that they are precipitates, so those are all going to be solids. Now the exceptions throws it to the other side of the chart. So if you have any of these exceptions, it makes it a solid. If you have any of these exceptions, it makes it an aqueous substance. Now down here, just for some extra information, if you have water, it's always a liquid. Carbon dioxide is always a gas. Your Brinkelhoff elements, bromine is a liquid, iodine is a solid, everything else is always a gas. And then all of your other elements are always a solid except for mercury is a liquid. So I just wrote those down to have those extra information when I am going through my examples. So what you do with this chart, I'm going back to the examples that I did in the Predicting Products Predicting Products video, and we predicted the products in the last video. Once we predict the products, we also predict the state of matter of the products. And when we predict the state of matter of the products, that always goes after the formula in parentheses like this. So I have CaCl2, and I need to predict the state of matter for that one. So I have calcium. When you look at these, group 1 in ammonium, these would be listed first because they're cations. So if you have group 1 So you have lithium, sodium, potassium, hydrogen, any of those group 1 elements. If those are listed first, it's going to be automatically aqueous. Same thing with ammonium. Everything else, you're going to have to look at the cation. Ignore the cation, you're going to look at the anion, because everything else through here is all an anion. So I need to find chlorine. Chlorine is kind of hidden down here with your halogens. Halogens are in group number 17, and I'm dealing with, in this case, calcium with your chlorine. So I'm going to look at my halogens. Halogens are always aqueous unless it's combined with silver, lead, or mercury. I don't have silver, lead, or mercury in this case. So that means that this is aqueous. So I'm just going to put an AQ after it. Again, you're only predicting the products and you're predicting the state of matter of the products. I don't care about the reactants because typically those are always going to be aqueous. Now the second one, we have H2CO3. There was a little bit in your notes though about this one. Your H2CO3 automatically breaks apart into CO2 and H2O. Now for your states of matter there, if you have water, water is always a liquid, so we're going to write an L there. Carbon dioxide is always a gas. So I'm going to write a G there. So I didn't have to use the chart, just water is always a liquid, carbon dioxide is a gas. So that one would have 3 products on it. And then after I do that, I could balance it, but I'm not going to worry about balancing them for this video. The next example, I have copper that I need to predict the state of matter, and then this iron 3 sulfate. So with this one, copper is a single element. With copper being a single element, we're off the chart, we're down here. It says all other elements are always a solid unless I have mercury, which is a liquid. So my copper in this case is going to be a solid. Now this iron with the sulfate, iron does not live in group number 1 on the periodic table. So I need to find sulfate on my chart. When I find sulfate on my chart, it's down here. And it says sulfate is always aqueous unless it's combined with calcium, strontium, barium, or lead. I don't have an exception to the rule. So with my sulfate here, I'm going to make this aqueous. The next one, I am making H3N. Again, I need to predict the state of matter. Hydrogen lives in group number 1 on the periodic table. With hydrogen living in group number 1 on the periodic table, all group 1 ions are always aqueous, no exception to that rule. So I'm going to write down AQ here. The next problem, I have 2 states of matter. Mg3PO42. So I'm going to find phosphate on my chart because magnesium lives in group number 2. It does not live in group number 1 on the periodic table. So when I find phosphate on my chart, it's right here. Phosphate is always a solid unless it's combined with group 1 or ammonium, which I already know I don't have group 1, and I definitely don't have ammonium. So this one is a solid. Calcium chloride. Calcium does not live in group number 1 on the periodic table. It lives in group number 2. So chlorine, again, is down here. It's a halogen. Halogens are always going to be aqueous unless it's combined with silver, lead, or mercury. I don't have any of those exceptions, so this one is aqueous. The next example, I have a combustion reaction. For my combustion reaction, I'm making CO2 and H2O. I don't use the chart for either of those. Carbon dioxide is always a gas. Water is always a liquid. The next one, I'm going to have to kind of squeeze these down here because I am out of room. Sorry, my lights went off. Oh no, they're not going back on. Hang on. Sorry, I don't know why the sensor didn't work. So I have chromium with nitrate on the next one. With my chromium with my nitrate, nitrate is right here. There is no exception to that rule. Nitrate is always going to be aqueous. So this one is AQ. Now my silver with my chlorine. Silver does not live in group number 1 on the periodic table, so I'm going to find chlorine on my chart. When I find chlorine on my chart, it's a halogen. It's in group number 17. Halogens are always going to be aqueous unless they're combined with silver, right there, lead, or mercury. So this is an exception to that rule. So with this one, because I have a halogen with silver, we're no longer aqueous. This one is a solid. A few more examples and then I'll be done. All right, the next one, sodium chloride and bromine. Sodium chloride, sodium lives in group number 1 on the periodic table. Group number 1 is always aqueous, no exceptions to that rule. And then Br2, that's in Brinkelhoff. My Brinkelhoff elements are all gases except for bromine and iodine. Bromine is always a liquid. The next one, I have a Brinkelhoff element here. My Brinkelhoff element, hydrogen, all Brinkelhoff elements are always gases except for bromine and iodine, so that one's a gas. Now this one has aluminum sulfate. For my aluminum sulfate, I need to find sulfate on my chart, which is right here. Sulfate is always aqueous unless it's combined with calcium, strontium, barium, or lead. I don't have any of those exceptions, so this one is AQ. Down here, I have ammonium nitride. Ammonium is right here. Ammonium is automatically aqueous, no exceptions to that rule. Iodine, I2. For my iodine, it's in Brinkelhoff. Brinkelhoff elements are always gases except for bromine and iodine. Iodine is a solid. And then this one, Hg3P2. On this one, I need to predict my products. So when I look through, mercury does not live in group number 1. So I need to find phosphide on this chart. So when I look through on my chart, I don't have phosphide. Mercury is not in group 1. This one we cannot do for this class. It is possible, but we don't know. This doesn't happen very often. Most things will be covered by the chart that I gave you. We don't know, so we're just going to leave that one blank. You won't have one of those on the test, by the way. You'll always be able to predict it on the test. Or in the lab, you'll be able to see it. All right, lead to chloride here. Lead does not live in group number 1 on the periodic table, so I'm going to find chlorate on my chart. Chlorate is right here on my chart. Chlorate is always aqueous. There's no exceptions to that rule, so I'm going to write down AQ. Potassium phosphate. Potassium lives in group number 1 on the periodic table. With potassium living in group number 1 on the periodic table, there's no exceptions to that rule. It is always going to be aqueous. So I hope that that helps. Again, you're going to need this chart. The chart is either in your reference materials or it's on the back of the periodic table that I had copied for you. And then there is some extra information in your notes. If you guys have any questions, make sure that you ask. Have a good day.